Welcome, ladies and gentlemen. Today we're going to be talking about simplifying radical expressions. So you're going to need your notes, a pen and a pencil, and the calculators, please. All right, to get started, we need to know what a radical expression is. So if you write this down, that'd be wonderful. A radical expression is a fraction. This will contain numbers, variables, terms, and polynomials. Okay, in order to simplify them, we need to understand how to simplify fractions, first of all, how to correctly cancel things, and how to factor. Factoring is going to be huge, okay? So make sure we know how to do that. First thing we're going to talk about is how to simplify things correctly. So when we're simplifying things, we have to cancel factors, okay? Things that are exactly the same like factor, that means we have to talk about multiplication. So if you look at this first one, the incorrect one, if I would write this, 7 plus 3, it equals 10. And I have 9 plus 3, and that equals 12. So we're like, hey, the 3's have in common, so then they're going to be 7 over 9. But in this case, it's not going to work because we can't cancel things by taking away the addition, okay? So this does not work. What we need to do is we need to break things up using multiplication or factoring. So if I break down 10, two factors that equal 10 are 2 times 5. And then two factors that equal 12 that have something in common, so we can cancel it. We're going to have 2 times 6. Now that we're using multiplication, we can cancel things. So we're going to cancel out our 2's. So we're left with 5 over 6. That's going to be our answer for that one. So we can only cancel when we're multiplying things, okay? Everything has to be the same. That's going to be super important when we're talking about this. All right, moving on, we're going to do 4 examples today. Here comes our first example. So our first example, if we look at the top and the bottom, we have to figure out how to factor first. For factoring this one, we can only take out a greatest common factor. So if we look at this one, we can take out 20 out of both of them. So 20 is going to be written out in front. And then we're going to write what we have left over. So if I take out 20 out of 40, I'm left with 2x plus 1. Now I'm going to do the same thing on the bottom. Only factoring I can do is greatest common factor. So I'm going to take out a 10 out of both of these. So I'm going to write 10 out in front. And I'm going to be left with x plus 3. Now, in order to cancel these things, they have to be exactly the same. So right now, I don't have anything, but I can break down 20. If I look at 20, I'm going to break it down. So I'm going to have 2 times 10 to make up 20. Now, I can cancel out my 10s. So on the top, I'm left with 2 times the quantity 2x plus 1. On the bottom, I'm left with x plus 3. And we can't cancel anything else because it's not exactly the same. So this is going to be my final answer. All right, moving on to example number 2. Here it comes. So same idea, we need to figure out what kind of factoring we can use if we can. So on this top, I can use greatest common factor again. I can take out 2x out of both of these. So I'm going to write that out in front, 2x. Inside, I'm going to be left with x plus 4. On the bottom, I can't simplify that, so I'm going to leave it as 12x. Now, right now, only thing I can cancel are my x's because this is multiplication, so they're separate. But now I can break down 12. I can break down 12 to 6 times 2. So now I can also cancel out my 2's. So on top, I'm left with that x plus 4. On the bottom, I'm left with 6. And that's my final answer there. Okay, there's example number 2. All right, here comes example number 3. We look at example number 3. On the top, we have to see what we can do. Only thing we can do for factoring is greatest common factor. So I can take out a 2x out of both of these. So 2x is going to be written out front. What's left over? 2's cancel. One of my x's cancel, so just x. 10 divided by 2 is 5. And then my x's cancel, so that's what I have on top. On the bottom, I have 3 terms. I have that trinomial, so I have to use AC method. My A is 3, my B is 16, and my C equals 5. So I'm going to come over here, I'm going to do A times C has to add up to B. 3 times 5, which is 15. 2 terms that equal 16. So if I do that, I'm going to use 15 and 1. These 2 terms are going to replace that 16x in the middle. So when I do that, I get 3x squared plus 15x plus 1x plus 5. Now I have 4 terms, so I can use my grouping method. Group these first 2 together, and then the second 2. So I can take out a 3x out of both of these. 3x is out in front, left with x plus 5. My second one, I can't really take anything out, but I can always take out 1. So I'm taking out a positive 1. I'm left with x plus 5. Now I'm going to put that on the bottom. My answer, I'm going to have 3x plus 1 is 1. And my other one I'm going to have, these are the same. So I'm going to have my x plus 5. Now remember, when we cancel, we can only cancel things that are exactly the same. So if I look at the top, I don't have any multiples of 2, so that has to stay. On the top and bottom, I don't have x's, so that has to stay. But I do have, in parentheses, x plus 5 on the top and the bottom. So since they are exactly the same, I can cancel them out. So on the top, I'm going to be left with 2x. On the bottom, I'm going to be left with 3x plus 1. This is as far as we can cancel, because we'd have to cancel out exactly the same thing, okay? Nothing can be added and subtracted. So this here is my answer. All right, moving on to our last example. Here we go. Now, first thing, factor. We have to check, see what we can factor. On the top, I have an x squared minus 49. X squared and 49 are both perfect squares, and I have subtraction, so I'm going to use my difference of squares. So I have an x plus 7 and an x minus 7. So that one's taken care of. On the bottom, I have 3 terms, so right away I'm thinking AC. But before I get to that point, I have to think, is there a greatest common factor? In this case, there is. So I have to do my greatest common factor first. I can take out a 2 out of everything. So that's going to go out in front. And I'm left with x squared minus 2x minus 35. Once here, now I can AC it. And if we want to really quick, we can't forget about this 2. So if you want to make sure you write it down right away, you can. Okay? That has to go with our answer at the bottom. Now I'm going to do AC. So if A times C has to add up to B. So 1 times negative 35 is negative 35. 2 numbers that add up to negative 2. In our case, that's going to be negative 7 and 5. Take those 2 numbers and replace it with that negative 2x. So I have x squared minus 7x plus 5x minus 35. These add up to that negative 2x. Now I have 4 terms. Now I can do my grouping. The first part, I can take out an x. So I'm left with x minus 7. Second part, I can take out a positive 5. So I have a positive 5, and I'm left with x minus 7. Now I'm going to rewrite it with what I have left over. So I have x plus 5. So my 2 is already there, because that's a little brother and sister. Can't forget about them. Then I have x plus 5. And then these are the same. So I also have an x minus 7. Now I have to work on that canceling part. It has to be exactly the same. So I have an x plus 7 on the top, but if it's not on the bottom, I have to keep it. So I keep my x plus 7 on the top, but I have an x minus 7 next, and there is also an x minus 7 on the bottom, so that can be canceled out. So on the top, I have x plus 7. On the bottom, I have 2 and x plus 5. I have nothing else in common, so then those are going to be the same. So, sorry about that, ladies and gentlemen. That is all I have for you today. I hope you have a wonderful day. I will be seeing you soon. Bye!